Hi, I'm Bonnie Holub from ArcLight. This is a tutorial video in Microsoft Excel, 2 ways to do the same thing. Excel is a powerful tool with many different capabilities, and often as not, there's more than one way to do something. I'm going to show you 2 ways to build a data table today, and the reason I'm doing this is because I think that you will learn about mixed cell references as I do it that way, and about a 2-variable data table when I do it that way. And I think by comparison you'll be able to see different ways to do the same thing and learn about each of these techniques as I go. So I have a results sheet here which shows what I'm going to do and where I'm headed. The scenario is this. I want to buy a car, and the car I expect to cost $5,000. I can get a loan for the car for 3.5%, and this is an annual amount. I'm going to need the interest rate in a monthly amount because I'm going to make monthly payments. So down here I take the annual interest rate and divide it by 12 to get the monthly interest rate amount. Then I have the length of the loan. My bank is offering me a 3-year loan with 12 payments per year, so that the term of the loan is the length of the loan, 3 years times 12 payments per year, and so that gives me the total number of payments. And my monthly payment would be $146.51. Now there are several different lending institutions I'm talking to, so I'm shopping this loan around, and each of them has a slightly different program. One has a 2-year program, one has a 3-year, another has a 4-year program. At one I can get 2.5%. There are different rates at the different institutions, ranging from 2.5 to 5%. So I want to build a table over here that shows me all those possibilities so that I can determine what the difference is and what the trade-offs would be. As you can see, this table appears here twice. Here's the first one, here's the second one. That's the point of this tutorial, to show you 2 different ways to build this table. So I have a blank sheet here where I have typed in, I've copied actually, the labels from these cells in my results over here so I can start filling it in rather quickly. $5,000 is the amount here, and the interest rate is 0.035, which is the best way to always enter numbers and then put them into the right format that you want. Then this is an annual interest rate. This is a monthly interest rate. This is the length in years, and this is the number of payments. So I have those labels in there to make it more readable. So the payments per year are going to be 12. I had these 2 cells highlighted in the previous example because I want to name them. I'm going to use them in my formulas. So I go over here and I'm going to define a new name for this. I'm going to call it loan underbar AMT. And the reason I'm using an abbreviation here is because in my other sheet I have something called loan amount, so I want to differentiate it. So I'm going to use loan AMT on this sheet. Oh. I'm going to use loan underbar AMT. In my practice for this I've already defined that name, so I want to use a new one. So I'm going to call this one LN AMT. Then down here I want to give this a new name, so I'm going to call this one PPY for payments per year. Again, it would be better to name it payments per year, but when I practice this and put it on the other sheet, that name already exists, so I want a unique one, so I'm going to use that. Okay, so now I can say that if the length of the loan is 3 years, then the term is going to be equal to the length of the loan times the number of payments per year, and there's my name that I defined, so I'm going to use that. And up here the interest rate is going to be equal to the annual interest rate divided by the number of payments per year. Remember, that's the name I defined. You can see the little name tag here, and that's good. I'm going to also put this in a percentage format with 1 decimal place for this. Now I can enter my formula for the loan payment. So if we go up here and we say it is equal to PMT, this will get me into the payment function. It reminds me of the arguments that I need to use here. The first argument has to be the rate, and remember, it has to be apples to apples. So the monthly interest rate, since I want to calculate the monthly payment, times the number of periods. And in terms of months, there are 36 periods in this 3-year loan. And then the present value of the loan amount, which is up here in ln amount. So I should get the right calculation, 146.51, and I'm checking to make sure it's the same. Yes. Okay, so now let's start building the first data table. And this is the one that I'm going to use mixed references for. So over here is going to be my 2-year scenario, my 3-year scenario, and my 4-year scenario. And then over here, this is going to be 2.5%. So I'm going to put it in as 0.025, and I'm going to put it in as a percentage with 2 decimal places. And then this is going to be 0.03, and I'm going to use the format painter to paint that one down there. And now, because I have a series established, I can go ahead and I can drag this down here for 3.5%, 4%, 4.5%, and 5%. Now, since I'm going to use these in my other table, I'll just do a quick copy and paste down here so that I have that ready to go when I'm going to do that. But right now, I'm just working on this table up here. And I'll fill these just to make them readable. I should have done this before the copy, but it's easy enough to do now. Okay, so this is where we're going to use a mixed cell reference. So we're going to say equals the payment, and what we need to do is this. We need to say what's the rate? Well, the rate for this payment in cell F2 is 2.5% divided by the number of payments per year. Remember that name? Okay, so that's the one we want to use. Next, we have to tell it what the number of periods is. Well, it's 2 years times the number of payments per year, right? And then, comma, for our final required argument, we have to give it the present value of the loan, which is $5,000. And it picks up a loan amount. Now, part of the reason that I named these was so that I can copy it and not have it change as I copy it. So, let's look at what happens. When I do this, and I say Control-C, Control-V, oh, I get a bunch of errors. And of course, the errors are because I haven't made these relative references into the appropriate mixed or absolute references. As you know, by naming a cell, I get absolute references on the payments per year and the loan amount, so that's good. That's why I named them. Otherwise, I could have entered loan amount as $B, $1, that is a absolute reference, and I could have entered PPY as $B, $5, again another absolute reference, but in this context, since I'm naming only the cell, it is an absolute reference when I copy it. It's these two, the E2 and the F1, that aren't good for copying. So let's go back and see why that is. When we think about copying, let's think about this. This first one, E2, this is the interest rate. As I copy this over from this column to this, from the F column to the G column and the H column, I want it always to be in row E, so we need to cement that reference. So I'm going to put a $sign in front of the E. Do I want to cement the reference to the row 2? No, I don't want to. And the reason is when I copy it down from row 2 to row 3 to row 4 to row 5 and row 6 and 7, I want the row to change. So this is a mixed reference. It has a $sign cementing one of the pointers, that is the column pointer, but not the row pointer. Compare and contrast that to this one. When I look at this one, F1 is my loan number of years. As I copy that from F to G to H, I want it to change F, G, and H. What I don't want to change is this reference to row 1. The number of years is always going to be in row 1. So I'm cementing that cell reference. So look at how these are two mixed cell references. They each have a $sign in front of one of the pointers, either the row or the column. And it's different. In one, I want to cement it to the column on the left, and in the other one, I want to cement it to the first row. So go ahead and enter that here. When I say Control-C, Control-V, and paste, now I see that my numbers have changed appropriately, and I can even double check. This scenario had a 3-year loan at 3.5%. So a 3-year loan at 3.5% is this cell right here, $146.51, which was the same as my calculation over here. Okay, so to summarize, for this one, I used mixed cell references, cementing either the column or the row pointer appropriately so that I could take this cell entry and copy it, Control-C, Control-V, into all those cells. It's one way to do it. Here's another way to do it. This is a 2-variable data table. So the way you do this is in this cell, which is the intersection of your row showing the variables you want to change there, and your column showing the variables you want to change there. In this cell, you say, here's the calculation I'm getting to. You need to point it to the total. Then, when you highlight this whole thing, and you go into Data, and you choose your What If analysis for a data table, now it says, one of your variables is going to change because you have a row of variables that are different. Here's your row of variables that are different. Rows always go left to right. Columns always go top to bottom, like the columns in a Greek temple. That's how you remember that. So anyhow, the row cell, this 234, what is that substituting for in all of these cells that build up to this calculation over here? Well, it is the 234 substitutes for this length of time. What are the column cells going to substitute for in the collection of cells that lead to this calculation? The column input, which is up and down, is substituting for this here, right? The interest rate. So now when I say OK, it should fill it in, and it does. Now the formats are slightly different, so just to make sure we're looking at the same thing, this is a currency format. This is a general format. I'm going to put it in a currency format. I'm going to choose a currency format that turns them red when they're negative, but I don't know where there it is, this one. If I put it in the same format, you can see. First of all, you should double check this cell calculation. The result is the same as this one. This one's the same as this one. This is the same as this. This is the same as this. This one in the middle is the same as this one in the middle is the same as this one. So you can verify that you've gotten the same results but through two different ways. Which do you choose to use? It's up to you. Whichever one you find easier to use. It's one of the many ways in Excel when you can do the same thing two different ways. Now there's one thing left on the results that aren't on this, and it's this slider bar. So at this point in a 2-column data table, people usually demonstrate that in the Developer tab, which if it isn't on your tab, you have to go into File, Options, Customize the ribbon, and make sure that this developer box on the right-hand side listing, make sure it's clicked and checked. If you say OK, then the developer tab should be here. So when I go here, I can do an add-in. I can insert a form control, and the form control I'm going to use is the scroll bar. This is the standard thing people demonstrate at this point. I'm going to put a scroll bar on here, and when I right-click on it, double-click or right-click on it. Okay, here I go. When I right-click on it, I get the option to format the control. My current value is going to be $5,000, and I'm going to look at loans from $5,000 to $10,000. And the incremental change, one is very small considering the magnitude here, so I'm going to say $100 and a page change of $100. So now I just need to tell it what cell am I linking this to, and I'm going to link it to this cell, B1. So now I can say, well, what if I have to click on something else so it's not selected. Now I can go back and I can click on the scroll bar and say, this is, if I click on the down arrow, it increases it to a $5,100 loan. So this is for when I'm looking at two different cars and I want to compare and contrast them. You can also click on the up arrow and scroll all the way through. But what's important to notice here is that both of the data tables, because they're both keyed back to this loan amount, will change when you change this. All right, that's the example on how to do two different ways to do the same thing. One using mixed cell references and one using a two-variable data table. I hope you find this useful, and I hope I see you in other videos. Thanks for watching.